Okay, in the previous video, linear equation part 1, we defined what is first order linear differential equation, which can be written in this form: y prime plus px y equal to g sub x. So any equation can be written in this form. We will call them first order linear differential equations. Okay, now we know how to solve this equation. We can solve them completely. Okay. What do we need to do? Here, just review. Okay. First of all, we can find, we call this equation 1. Okay. First, we can find our mu, which is function of x, which we call integrating factor. Okay. Mu can be found by this way: e to the p sub x integration of it. Okay. So if we know p sub x, you give me a differential equation linear. So we know the p, we know the g. You integrate this, you find your mu. Okay. So once you find your mu, then we can find the y, which is our solution. It's 1 over mu times integral. Mu is a function of x, is given, and g dx plus c. Okay, we'll call this whole thing equation 2. Okay. So if we have been given a linear differential equation, like equation 1, then we can find the mu. If we know to find the mu, then we can find y. Okay. Now let's look at the example, see what we mean by that. Example 1. Okay. Now we want to solve this differential equation: xy prime plus 2y equal to 4x squared. Okay, first of all, this is a differential equation. Okay, we also want y have such a condition: when x equal to 1, we want y equal to 2. Okay. Now, without this condition, if we just solve the equation, we normally get infinite many solutions. But there's only one solution satisfy the differential equation at the same time this initial condition. Okay, so we call this equation 3. Now, is the equation 3 a linear equation? The answer is yes. Okay. So if it is a linear equation, then we can use the formula 2 to solve it. Okay. The most important step is to identify right p sub x and g sub x. So what is the p sub x here for the example 1? You would think it's 2? No, it's not. Okay. So if you want to write the equation 3 in the form of equation 1, then we need to divide x on both sides. Okay, so we got this. Okay, now we call this equation 4. Okay, equation 4 is same as equation 3. What we did is just divided x on both sides. Okay, now it's clear what is our p sub x. Right, p sub x is equal to 2 over x is the coefficient of y, but you have to make sure the coefficient of y prime is 1. Okay. Then g sub x here is 4 sub x. Now, we know p, we know g. Then we can solve it by using formula 2. So first of all, let's find mu sub x for this case. It's e to the integral. P sub x is 2 over x dx. So this is equal to e to the 2, you put the 2 out, then 1 over x dx, which we know is integral of 1 over x is ln x. So this is equal to e to the ln x squared. We use the property of a natural log function. Okay. So e to the e exponential function e and the ln, they inverse each other. So this will give you x squared. Okay, now if we want to use the formula 2, the next thing we want to find out is this one. Okay. We need to do another integration, which is integral mu g dx. Okay. For this case, our mu here is x squared. G of x is 4 times x dx. So therefore, this you got 4x to the third dx. Integrate that, give you x to the 4th power. Okay, now we can write our y. Okay, our y here, use the formula 2, is 1 over mu, which is x squared, times this integral, which is x squared, x to the 4th plus c. Okay. So we simplify that, we got x squared plus c over x squared. Okay, so we got our solution, which is y equal to x squared plus c over x squared. So with the different c, you got different solutions. For all the c's, they will satisfy this differential equation. Okay. However, if we want to also satisfy this condition, then c cannot be anything. Okay. So we know 1x equal to 1. We want y equal to 2. Okay. On the other hand, here you let x equal to 1. You got 1 plus c over 1, which is 1 plus c. So that tells us c must equal to 1. Okay. Finally, we find out y here is x squared plus 1 over x squared. Okay. So this is our solution. Okay. This solution, first of all, satisfies our differential equation 3. At the same time, 1x equal to 1, you can see our y equal to 2. Okay. So this example just show you if you got your equations are linear, then we can use the formula 2 to solve it. Now let's look at another example. Okay. This example is like y prime equal to y. Okay. And also y0 equal to 1. Okay. Now, this is equation 4. First of all, is this equation linear? Obviously, yes. Okay. Then, if you want to write in that form, it's like y prime minus y equal to 0, right? With the piece of x here is minus 1, and the g of x here obviously is 0. Okay. Therefore, we can use our formula 2 to solve it. Okay. First of all, find our mu. Mu here is e to the integral piece of x, which is minus 1 dx, is equal to e to the integral minus dx. So give you e to the negative x. So we find the mu. Okay. Then to find the y, we just need to do this. Use the formula 2. 1 over mu times integral. Mu times g. Okay. Mu here is e to the negative x. G is 0. Okay. Dx plus c. Okay. So we integrate 0 there. You got a 0. Therefore, we just simply have like 1 over e to the negative x times 0 plus c. Okay. So we simplify that, we got c times e to the x. Okay, for different c, we got different solutions. So we have infinite many solutions. Now, if you want your initial condition to be satisfied, so then C can be uniquely determined. 1x equal to 0. You want your y equal to 1. Okay. Therefore, we have like C, let x equal to 0, e to the 0 equal to 1, so equal to C. Then C equal to 1. Okay. So finally, we solve that. Our y here is equal to e to the x. Okay. You can check. This one satisfies equation 4. Okay. Okay. Now, if we want to draw this, here is x, here is y. Okay. So this is a solution, which is a curve like that. For different C, you got a different curve. Okay. You got it like this. Now, say, for example, at a given point, I give you this point. So you have x and y. You plug in this equation, you can find is a derivative, is a slope. So at every point, you got a slope like this. This is what we call the vector field for this differential equation. So vector field of differential equation that related with the solution. Okay. Now, we can draw a vector field for given differential equation without solving it. So normally you have equation like this. If you give me x, y, okay, like think about this. What is the vector field for that? Give me x, y here. Then you plug in. You find y prime. That means you got direction. Okay. Give another x, y, you got another direction. You do that everywhere, you got a vector field. Now, let's look at what is the vector field for equation 4, for this equation. Let's look at it. X and y. For example, at this point, say here is x is 1, y is 0. Okay. Now you plug in there. So look at this equation. Okay. Whenever you see x replaced by 0, whenever you see y replaced, when you see x, you replace by 1. When you see y, replaced by 0. So you don't see x there. So you see y there is 0. So at this point, your slope is 0. And at this point too, right? Because your y is 0. So like this. Okay. For example, let's look at this point. Say it's 1, 1. X is 1, y is 1. You plug in here again. Y is 1. So your y prime is 1. Okay. And the same here, because there's no x there, so as long as your y is the same, you got like that. Okay. Okay. Like this. If y equal to 2, y prime equal to 2 here, so you got a bigger slope. Like that. If this is bigger, then more steep. Okay. So here's like the same thing. Okay. That's what we call vector field. Okay. Now you can see that you have a curve go like that. That's our solution. Okay. So if you're asking to draw the vector field, that's what that means.